Good morning and welcome back to KXAN Plus. I'm your host, Esmeralda Zamora. If you're watching us live today, happy Tuesday. Thanks for joining us. Remember, you can also watch us on demand now on the KXAN Plus free streaming app, anywhere you get your streams. But let's get on with this segment. We have our space-based segment with our KXAN space expert, Eric Henrikson. Eric, how are you doing this morning?
I'm doing fabulous. I've had a lot of fun science stories the last week. I'm vibing. Is vibing okay? I'm vibing
You're
today.
vibing? When I said Tuesday, you were kind of confused.
Well, time and space have collapsed on my brain.
There's a lot of collisions.
I don't know what
on the
day it
horizon.
is. All I know is you messaged me and said, come on down. I was like, all right, let's go. Let's do this.
Let's do it. So today we're going to be talking about black hole clashes and some new discoveries that have to do with
Yes,
them.
we have an object that is flying into the solar system as we speak. Discovered from outside the solar system. Ooh, what is it? Oh, we have an answer. It's not it's not as scary and mysterious as I'm gonna make it sound, but the coolest one we'll start with life on Mars.
And that's one we're always talking about.
I know, and this one we actually have, I don't want to say proof, but like something
details?
along those lines. Yeah. So last Wednesday, I'm doing the math in my head. Last Wednesday, NASA announced that the Perseverance rover found rock samples in I keep forgetting the name of the crater, the Jezero crater, that showed potential signatures of life on Mars. So potential signatures. I want to be very clear. Potential signatures. So that's kind of like, we didn't find little green men.
Little specks of molecules,
Yeah,
maybe?
they're like parts of the rock that they look at and go, that's what remnants of life look like on Earth and other specks of rock. Wow. So we have comparison points to Earth. But these specks, I know it's like we're saying like specks, it's pretty simple, but it is specks. But this is, when we're talking about life on Mars, I think a lot of us still think about War of the Worlds, and there's going to be these craters, there's going to be these giant tentacled creatures that come out and turn do all sorts of stuff to our planet, and then viruses get them there. That's a spoiler for a 100-year-old book. But it's not like that. Mike Tice from Texas A&M is one of the people who researched life on other planets and life here on Earth, and he had this to say about what life is on other places.
So when we're talking about potential life on Mars more than 3 billion years ago, it's really important to realize we're not talking about little green men or creatures that would run in front of the cameras and smile as they went by. So even today on Earth, most of the life on Earth is not organisms the size of me. They're little bacteria and single-celled organisms that they live everywhere. They live on us. They live in the sand on the beach. If you go to Yellowstone, it's actually a great place to see piles of microorganisms growing in hot springs, and they make these green and orange mats. That's the kind of stuff that we're most likely to find if we see ancient evidence of life on Mars.
I like how he said, you're not going to find little green men running around smiling at the camera. You're going to find little specks of rocks.
I mean, that's what it is. Most life on the planet is very small. It's, single-cell organisms, stuff like that. Yeah, to reach human shape requires...
we're still very small, right?
We are. When you're talking about we've talked about this before. We're talking about the universe. We're ants, not even ants. We're single-cell organisms. But if you just on a planetary scale, to reach this, which come on, this is a lot of work. So it takes a lot to get here from an evolutionary standpoint. So most life that exists is single-cell organisms. It's plant life. It's algae, stuff like that.
So what does that mean for the discovery? I know we haven't discovered a full human body or extraterrestrial, but we're finding little specks of potential life. Does that mean that it could later develop into a human up there or something like that?
Likely the reverse. Likely there was something and now it's gone. So Mars has no atmosphere, a very thin atmosphere. There are theories that it once had a much thicker atmosphere, and when you have a thicker atmosphere, things like greenhouse kind of conditions exist. You have greenhouse gases, things like that. Yeah. And I'm actually looking to a story on that on Friday, so we'll have more next week. Talk about that specific part. But the gases allow for there to be an atmosphere and allows there to be water, and then within water, cells can develop into multi-cell organisms in life. but Mars now, the atmosphere is very thin. Something must have happened in the ancient past, if life existed.
That's scary.
And
I
we
don't
think
want
it
that
did.
to happen to
Something
us.
must have happened to Mars. No telling what it was. It's something about Earth's kind of a weird thing when you look at the number of planets we have. It's kind of a odd man out. So it has the conditions, the atmosphere, the humans on board, humans living here. Humans live on Earth to kind of keep it in a condition. But Mars, something must have happened to thin out the atmosphere over time. And when that happens, whatever life was there, with stuff like this, since this is what we're seeing, it probably, if it existed, my guess would be single-cell organisms. There's other places in the solar system, not saying the galaxy, just the solar system, our solar system locally, like Ganymede, Io, Titan, these moons of Jupiter, that possibly also could have had life. And if they have it, I think it's, Europa. Europa, one of the moons of Jupiter, it has a big, thick, icy shell, and there's an ocean beneath there. And so we actually anticipate if there's any like multi-cell organisms, they would be there on Europa. But how we find life on Mars and here, even on Earth, is it's kind of complicated.
Is it that machine from that video?
So
that
that's
was
like
playing?
drilling the holes and like taking out samples.
What is that called?
That's Perseverance. That's the rover. And so it has like different pieces on it. I don't know all the individual pieces.
How many samples has it collected so far?
Let's see. I think it took about 30 samples. It's going to take 36 samples eventually. And those are going to remain on Mars. But Mike Tice also talked about, again, from Texas A&M, about how we find life. And you can check that out here.
So when we're talking about potential life on Mars more than 3 billion years ago, it's really important to realize we're not talking about little green men or creatures that would run in front of the cameras and smile as they went by. So even today on Earth, most of the life on Earth is not organisms the size of me. They're little bacteria and single-celled organisms that they live everywhere. They live on us. They live in the sand on the beach. If you go to Yellowstone, it's actually a great place to see piles of microorganisms growing in hot springs. Because we're talking about things the size of bacteria, single-celled organisms, and looking for evidence of them, it's really difficult to just walk up to a rock with a camera and to see direct evidence that microorganisms are around. And so a lot of what we do is look for evidence of their breathing, their metabolic activity, and that comes in the form of redox reactions. Some of the best ways to see redox reactions are just to leave a cast iron skillet out and let it rust. That's a redox reaction. This was happening on the Earth more than 3 billion years ago. You see these red layers in this rock where probably organisms were performing redox reactions with iron and producing, in this case, this nice red color. And in the case of the rocks on Mars, we're seeing places where they were taking iron that was like this, breathing it, and forming other minerals that were reduced in a different color in the center of these leopard spots, or the reaction fronts.
I like how he showed that rock in his
Right.
hand and explained, like, this is the type of stuff that we're finding.
Yeah, we're seeing these layers on the surface, but we're seeing these layers on Mars that are, showing, hey, there's possibly life that existed here, creating these chemical reactions. So,
And it's similar to what we have here on Earth. I know there's a lot of spots around the United States where people go hiking and they take pictures and they say, oh, we're on Mars, because it looks exactly the same.
I mean, it really does. And you can see similar layering like that all over the place here in Central Texas. If you go anywhere where the Balcones fault has happened, which is like the green belt, you can see it there. You can actually see like those layers in the rock. Have you ever been to the Grand Canyon?
No, but I do want to go one
Grand
day.
Canyon, you can see those layers pretty distinctly. There's, I think it's called the Painted Desert, is another area on the road out to the Grand Canyon that has the same layered structure.
And it's a certain element that causes that?
Yeah, it's just different. So you can see again the history of the planet and the elements that exist at the time. And I'm curious in a few million years
What it's gonna look like?
ours will look like, the layer where humans existed.
Well,
What that will look like.
what do you think it's going to look like?
Oh, it's probably gonna be really, really messed up. all the stuff we're breathing into the atmosphere, all the carbon dioxide and everything, all the greenhouse gases. Again, we're talking about potential life. I want to kind of emphasize this again. They did not find aliens.
Not little green aliens.
No green aliens on Mars. Roger Wint, I believe is his name, from Purdue University, talked again about the potential discovery of life, and I want to show you what he said.
One of the things we have to make clear is that these are potential biosignatures. There are possible other explanations for them, and so we have to kind of really check those out too. But when we put all of the facts together, one of the most likely possible explanations is that of a biosignature in the ancient record on Mars. And so we call these potential biosignatures. But it's the closest we've come to finding something like this outside of Earth.
The closest we've come. That's interesting.
I wanted to crush your dreams just a tiny bit and then build them back up again. So yeah, it is the closest we've come to finding alien life. Pretty huge. It's pretty big discovery.
Seems like a small step, but I'm sure it's a huge step.
Every
right?
small step is a huge step.
That's true.
One step at a time. There's some ancient saying about that. Anyway, we'll find out more in the future. What we're going to have to do next is send people to Mars to pick up the rocks and look at them closer. There's only so much data you can pull from a machine. The machine has to be designed to pull that data, and so a human can do a lot more.
If they're there physically.
Yeah, and also they can bring different equipment and check it out. Now that we know what we're looking for, we can look for other things. So, every step counts, and we'll learn more about. The cool thing is we learn more about life other places. We can learn more about life here and change how we do things.
And hopefully save our planet, right?
Hopefully save our planet. The whole thing about discovery is, you discover one thing, and you may not understand why we discovered that, but the information they use to either try to discover that thing or in the discovery of that thing, sometimes it frequently reverberates back home. So, speaking of reverberations, I'm talking about black holes for a minute.
Yeah, what is this Stephen Hawking's theory?
So, the theory of Stephen Hawking, that this new research it was an international research, some of the UT Austin scientists participated in this research, was that when black holes cannot lose surface area. So if two black holes collide, they will actually grow. And so this theory came about as a result of Einstein's theory about gravitational waves, which originated decades ago. And so these two theories, 10 years ago, in 2015, we detected the first set of gravitational waves, proving Einstein's theory. And gravitational waves are ripples in space and time that occur when black holes collide. And they're huge waves, but also very tiny waves at the same time, big intergalactic waves, but they're very, very small. And to the point where they stretch and pull the protons in our bodies when they hit us. We don't feel anything. It's that small of a change.
Wow.
But that was proven in 2015, and now new research is showing that when two black holes collide, as research that has been done to further understand gravitational waves, we've taken a better look at black holes. When they collide, which happens pretty regularly, don't worry, it's nothing to worry about, but when they do collide, they actually grow. It becomes basically, it's like 2 equals 4. 1 + 1 = 2 would be a better way of doing it, I guess.
And in comparison to like one of our planets, sun or moon, what
Did I
kind
put
of
the
size
math
is
here?
that?
I can't remember if I put the math here or not. It's so the two black holes were, when combined, were 30 to 40 times the sun's mass. Oh, they were 30 to 40 times the sun's mass each. I wrote this like a week ago, so excuse me for trying to remember numbers. But they went from a 92,000 square miles on each of them pre-merger, so 92,000 square miles to 154,000 square miles when combined. So yeah, they combined and they grew into one. Two small black holes grew into one big black hole. That's basically what happened.
Wow.
I did a cool story on this, looking at the history of discovery when it comes to gravitational waves and what the new research is, and we can take a look at that now. This concrete building in Washington State may not look like much. 10 years ago, it was responsible for one of the most important discoveries of our time.
Ladies and gentlemen, we have detected gravitational waves. We did it.
Gravitational waves were first theorized by Albert Einstein.
These are ripples in space and time itself.
Aaron Zimmerman with UT Austin is part of the team studying gravitational waves, which
actually allow us to see the part of the universe that is dark, that is otherwise completely hidden.
Chad Hanna with Penn State University.
They were detected from the first time from the merger of two black holes.
That first collision was detected in September of 2015 here at the Laser Interferometer Gravitational Wave Observatory.
LIGO is the most precise measuring device ever built.
Turns out black holes collide a lot.
In that moment where the black holes are colliding, more energy is coming out than all the stars in the universe shining.
This week, a new discovery by the LIGO team. When black holes collide, they don't just release energy.
As these two black holes become one, they are joining together.
The surface area of the newly merged black hole equaling the combined surface area of the two smaller black holes, something theorized by Stephen Hawking.
It's kind of like exploring, new continents, new worlds.
Zimmerman says that discoveries like this won't change our day-to-day lives.
But the methods we invent to learn more about gravity might change your life tomorrow.
In Austin, Eric Henrikson, KXAN News.
Wow, so it's a discovery of a new life, pretty much.
Sure.
It's like a new universe.
A
out
baby
there
black hole, yeah.
that we can't see unless they merge.
You can see the light warping around it, but we can't detect unless they merge, yeah. So that's how we detect them, is when the gravitational wave goes. What's cool about this is when the wave hits, when they combine, it was described as like a ringing of a bell. So when you ring a bell, it goes.
That's what the wave.
Yeah, that's what the wave
like?
did as it kind of rippled out. I don't know. I thought that was just kind of a neat little.
Can you hear that if you were right next to it in space?
No. It's not like an audible hearing. It's you more like would feel it.
Oh.
I think. I don't know. That's gravitational waves are weird. We don't feel them. They're so small. But I mean, it would.
They don't affect us down here, but they do.
If you were too close, I think the black holes would definitely do something to you. But
swallow you.
Maybe warp your time and space around you.
No, thank you.
But I don't. But that's the thing. Like our brains can't really comprehend that. So who knows? Or maybe they can. We haven't tested that theory yet.
And how would we test that? Just send people out there next
Probably, yeah. I don't know if there's an easy way to test that. There might be. I think the best way is to detect things with things like LIGO. Let the waves hit us, and we'll study that way. Yeah. Let's not jump into a black hole, shall we?
Well, they were so excited when they found out that they actually discovered that. And
it's this old theory, and now we have proof that they exist. So pretty interesting. That Einstein guy. Pretty smart.
Pretty smart feller.
Pretty smart feller. He. I wonder if he said anything that was like, that's a little out there, and then it wasn't true. Just made stuff up. Just was like throwing things out there, and people were like, "Yeah, sure, Einstein. Yeah, Albert, we'll do that." And then it's like The Simpsons. You ever hear? I have a thought. This thought follows. You ever see like on The Simpsons where it's like The Simpsons predicted blank, or they predicted that. It's just because there's been 9,000 episodes of The Simpsons.
So they
throw
have
out enough
try
stuff.
Everything.
Yeah, they have enough stuff out, enough jokes that people make connections. I wonder if Einstein did that too, just threw out a bunch of theories under the hopes.
One of these bound to work.
This I don't think that's true. I don't think it's true, but now I'm thinking it might be true. So it's somewhere in the middle. But yeah, I proved Einstein's theory of gravitational waves 10 years ago, and now we have proof of Stephen Hawking's theory.
So what does this mean for the future?
More studies of gravitational waves, and that technology they use can hopefully help us. They have really sensitive devices they use to measure gravitational waves. So that sensitivity will hopefully, it can come back to our own technology in different ways. Finally, we had a weird object enter the solar system.
Was it a black hole?
No.
A comet?
This was a comet. So it's actually only the third object ever detected from outside of our solar system entering our solar system. Since we've started detecting stuff, and we've been watching the stars for hundreds of thousands of years, but not really documenting or studying them. So this is the third one that we know for a fact. The last one came in 2017, and it was a name I'm going to try to pronounce. You ready? Oumuamua. Oh, I messed that up.
That was good.
Oumuamua. Yeah, something like that. I heard the guy pronouncing it like 20 times, and it's still not sticking. I'm sorry. I don't know who named that, but I blame them. Anyway,
scientists and their weird names for things.
So that object was like weirdly shaped, and so people thought, oh, it could be an alien ship. I think it was kind of like cylindrical, and this is 2017, but we don't really know. We put up hypothesis, and we make guesses, and they think it was probably like a comet or something.
How close is this new one to us?
Not close at all. Right now, it's like way out there next to the other planets. I think I wrote down the date. It's like 2030. It gets close to us.
Oh.
I don't think I wrote down the date here. I didn't. It's like 2030. It gets close. It'll pass between Mars and the sun. This is how far away it'll get, but it's not going to get close. And then it's going to spin back out. But it is a comet, is what they
Will we
believe.
be able to see it, or
Yeah, we'll be able to see it when
something?
it's that close. We might well see like a comet trail. It's called 3I Atlas. Oh yeah, I do have the date. I'm stupid. It'll close passes to Earth in December. I don't know where I got 2030 from.
this December?
This December.
Okay, so
December
it's
19th.
close.
I don't know where I got 2030 from. That number was holding in my head for some reason. I did write things down. I am smart to write notes because I don't remember
It
numbers.
says 2025.
It says 2025. It gets 170 million miles away, but it does pass like between Mars and I'm doing like I gotta hold my hands up here. It goes like Earth, Sun, Mars, and it kind of does like that. So it's like doesn't get close to Earth.
but
really.
it's like,
Passes within the
Nice
Mars
distance.
orbit as it kind of like arcs back.
what would
It
happen
will
if
get
it
in
did
within-
get close?
Nothing. It's too far away. It's safe. Hard to break it. Sorry to break it to you, but we're fine. But it will get like it goes like within the orbital ring of Mars, but doesn't. And it's not gonna like pass Mars either. It's just within that ring. So if you have like a grid, it's gonna go within the section that's like this is the Mars section.
Yeah.
When it circles back out, but when it's funny because it gets it goes close and then
Back out.
heads back out. Wait, it circles the sun because that's like pulling it in. But sun, it'll go within that ring and come back out. It gets close to us after it gets close to the sun, which I think is kind of cool. But yeah, December 19th, 2025, this year, not to 2020, 30,
Not
2030,
2030.
20, I don't even know. I can't do numbers anymore. So unlike the 2017 one, we do know it's a comet. And Stephen Douche from was it Arizona State University, he took a look at this and kind of explains why. And here, take a look at that.
So when 3I Atlas entered the solar system, it was immediately recognized that this object, unlike Oumuamua, was actually doing all of the things we expect a comet to do. It was discovered pretty far from the sun, so at the time, it wasn't hot enough, the ices weren't sublimating at that point in time, so it wasn't doing all of the things comets do when it was first discovered in early July. By late August, it was doing all of the things comets are expected to do. And as we go forward, we expect it to turn sideways around the sun. We'll get a better vantage point of its tail, and it has a tail just like comets do. We expect to be able to detect more gases in its coma, and we're looking for certain key gases, maybe looking for the rate of water vapor versus carbon dioxide vapor, looking for nickel and iron emission, obscure things maybe, but we're looking to see more of the gases we expect comets to eject because so far it's been ejecting them just like comets do.
So it started pretty slow and then quickly started
Yeah,
gaining that traction of an
if
actual
you think
comet.
about like the sun as a big weight on a sheet,
Mhm.
as you got closer to the sun, the weight of the sheet of the sun on the sheet pulled it down.
And sped up.
Yeah, as
all
as
the-
you get closer to gravity, kind of it gets a hold of you and
takes
kinda
control.
tugs. Yeah, so it likely originated billions of years ago in a different solar system.
We discovered it in July
Right. And so it's coming out. It'll come back in December, and then it'll circle back out.
2030.
Through the 2030, 2025. I don't know why I have 2030. That's going to bug me all day. It'll provide us some samples of chemistry from outside of our solar system. Not actual samples, but like we'll be able to scan and get images, see the chemical makeup on it based on the tail, based on the colors, that kind of thing.
And there's no aliens on board.
There's no aliens, so scientists have rejected all claims that there are aliens. Like the 2017 one, people were like, oh, what is it? But it's
What's on
important.
it?
Yeah, but it's important not to like completely rule it out, but like have a hypothesis, test it. And Stephen from Arizona State University again talks about that. So here's why we rule out aliens.
The idea that this object from outside our solar system might be not natural, that's a very natural question to ask. And especially when Oumuamua was the first object discovered, and it reminded us of the spacecraft in Rendezvous with Rama. So it was just really natural to think. And we always should be alert to these questions and not ignore them. And I don't think any of the scientific community is ignoring these questions. But when we look at this object, at Oumuamua or 3I Atlas, and we see, oh, right, if it's a chunk of ice or a chunk of ice and dust, then we expect it to do certain things, and that's what we see. We see it doing those certain things. Then we can have confidence that that's what we're looking at. And if we weren't prepared to say, I don't think it's a spaceship this time, I don't think it's a spaceship this time, then we wouldn't have credibility when maybe sometime in the future we see something, we're like, that doesn't look like a comet to me, that doesn't look like a chunk of nitrogen ice to me. We need to know all the possibilities so we can say, that doesn't look like anything we know about. Yeah, then maybe that one could be a spaceship. We want to have credibility as scientists when that day finally comes.
I like how he said when that day finally comes.
I know, I was thinking that too.
It's
I was
coming.
like very optimistic. Yeah, it's coming someday. Who knows when? Oh, mua, mua. There we
I
go.
heard him say it. Oh, mua, mua.
I listened to him say it like 10 times before I walked down here. Could not remember how to say it when we actually had to get
That's
to the word.
an interesting
Oh,
name.
mua, mua.
Mua,
I wonder what the origins are. I do remember that happening in 2017. I just don't remember all the details of that happening. But anyway, yeah. So we started with the aliens. We're ending with the aliens, but not
And
really.
the truth is, there's no aliens.
Truth is, there's potential life on Mars, so there is aliens.
Not aliens yet.
No, you and I are arguing on this one. Potential life, I count as aliens.
Yeah, but they're like little rocks.
Yes.
They can't come take over our planet.
Is that what you want?
Well, I mean, it seems interesting.
It seems interesting. Okay, I'm gonna introduce you to some hobbies that don't involve alien conquering.
I want
Earth.
them to come here and say, you guys don't have to do anything, just relax and have a vacation.
You have a much more positive outlook on aliens than I do. If they're gonna come here, I've seen signs. It's one of two good things. Neither of them are good for us.
I don't like scary movies. I'm not watching that.
Oh, Signs is a good movie. I like Signs. That's a very good movie. Anyway, that's our show.
That is our show. Aliens, no aliens.
And black holes
comets,
colliding,
black
creating new
holes.
life. I like how you tried to make the black holes combining into like a life form to kind of connect the dots better on today's show.
But it doesn't.
But no, it doesn't.
That's not how
I
it
hope
goes.
black holes aren't alive, because if they are, ooh, that tells us something big.
Then I'm really scared.
Yeah, you should be.
Well, we have this article that has been published on our website.
Yes, we've had that up. I had it from last week, but you know what? It's still cool.
It is cool. What
So-
can we find in this article?
More information on black hole research, more information on the bells ringing, which I think is still pretty cool. That right there is the actual wave, the gravitational waves. I didn't get to include that on my story because there's just so much stuff. And actually, those are actual photos of black holes, by the way.
This?
Mhm.
Whoa, I didn't
Yeah.
think they looked like that.
Yeah, I mean, not the best photos, but we're working on the
It's something.
technology. Yeah, we're getting there. We're getting there. And I put some cartoons in there too.
And a nice little video
You know, I love a cartoon.
explaining.
Yeah, I like to explain these things as best as possible.
Interesting. Well, if anyone is interested in reading more on black holes and clashes and all that fun stuff, it's on our website, KXAN.com. Eric, thank you for joining me. For anyone who wants to rewatch this video or watch our previous space-based videos, where can they do that?
On KXAN Plus, available on Apple TV, Samsung, Fire Stick, and I'm missing one. Google?
Google,
Google Chrome. What's the other one?
Apple, Fire, Samsung, and Roku.
Roku. My
Yeah.
Roku is on my Samsung. It's not like a stick anymore. It's just like on the
Oh,
app.
that's
It's just an
cool.
app. Yeah, so that's why I was free Roku.
I have a Samsung TV, smart TV, but I put a Roku in it.
You did not need to do that, by
I
the way.
did not need to
it's
do
on
that.
there. It's an app. You can watch Bake Off, American Bake Off, or Baking Show. I think it's called a baking show in America. You know what I'm watching? You know what I'm talking about?
No, but
The
I'll
Great
look
American
into
Baking
it.
Show, which is just the Great British Bake Off.
Oh, but
But they call
America's
it baking.
version?
Well, it's like a whole like Pillsbury owns the word Bake Off.
Oh,
So I don't know if anyone else is a big fan of that show. It comes on every Friday
on
in my
Samsung
house.
TV.
Well, the new season's on Netflix, but the American show is on Roku.
Nice.
So it has the same
Interesting.
judges. Okay, we'll stop talking about Bake Off. That's also about creation. Do you like cupcakes? That's the show for you.
If you watch it, let us know what you think about it. Send us an email.
Give us your review.
Thank you, Eric.
Thank you.